Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 4 from the specimen paper of the Mechanics M1 paper 4 from the Cambridge 9709 International A-Level syllabus. So this is a specimen paper for the post-2020 exams, and this question here is about statics. You have a particle of mass 20 kilograms is on a rough plane inclined at an angle of 30 degrees to the horizontal, as we can see there on the page. A force of magnitude 25 newtons acting at an angle of 20 degrees above a line of greatest slope of the plane is used to prevent the particle from sliding down the plane. The coefficient of friction between the particle and the plane is mu. Complete the diagram to show all the forces acting on the particle. Okay, so here we have a particle of 20 kilograms is on a rough plane. So a few things that we have to be careful and realize. A rough plane means we're going to have frictional force acting. At an angle of 30 degrees to the horizontal, a force of magnitude 25 newtons acting at an angle of 20 degrees, that's shown, is used to prevent the particle from sliding down the plane. So the particle is about to slide down the plane, and this force is helping to stop it from doing so. The coefficient of friction between the particle and the plane is mu. Complete the diagram to show all the forces. Okay, some people don't understand what it means here. At an angle of 20 degrees above a line of greatest slope of the plane. I mean, a lot of students don't understand what that means. It doesn't really affect the question too much, but for your understanding, just supposing we're looking at the plane side on. Let me just sort that. It's too thick. All right, so you have, say this is the plane, like a ramp. Okay, so we're looking at it side on. So this particle is at rest somewhere on this plane, and there's like a force that's pulling it up. Now basically what it's saying is that this force of 25 newtons is acting kind of like parallel to straight up the plane, not at an angle. It's not like pulling at an angle of the plane. It's straight, the shortest distance up here, line of greatest slope of the plane. So it's pulling it directly, along this line, straight up the plane, not at an angle. It's not going up at an angle. It's not pulling at an angle, something like that. That's okay, basically how you can understand what that means. As I said, it's not so critical for us to understand what that means in answering this question, but that's what it means. Right, so now, part A, 1 mark, just draw the forces acting on the particle. They've drawn the force of the string that's pulling it up, and now we have to also, or the force that's pulling it up, we have to draw the other forces. Now you have the weight of the particle. The weight of the particle acts straight down. Okay, so that's the weight, which is 20g. I'll just draw it. I'll put 20g there. So 20g newtons. You have the reaction force perpendicular to the surface. The normal contact force is called, we'll call it R. And then you have the frictional force. Now, it mentions it's used to prevent the particle from sliding down the plane. So we'll draw the frictional force acting upwards. So this is a frictional force. So those are the 3 forces, apart from the force they already told us, which are acting on the particle. Okay, so that's 1 mark for drawing those 3 forces. Now for part B, it says find the least possible value of mu. Right, so what I'm going to do is I'm going to just use the same diagram again. I'm not going to draw anything on this because this is like the answer to part 1. So I'll kind of draw it again, and then we'll continue. Okay, so here the forces I've drawn so far. So it says find the least possible value of mu. Now, what we know is F max, the maximum value of friction that can be generated, is equal to mu R. Okay, F max equals to mu R. And we want to find the least possible value of mu. Now, we know that the frictional force can vary between 0, for example, if there's a block on a plane, on a horizontal plane, and it's a rough plane, and there's nothing trying to pull it either way. Okay, you have its weight, okay, and you have the reaction force, okay, and there's nothing pulling it, the frictional force will be 0. But if you have something pulling it this way, then the frictional force will act opposing the motion, and the frictional force will be equal to the force pulling it if it's in equilibrium. But there reaches a point where the frictional force cannot increase anymore. So if this keeps increasing and increasing, Okay, this will keep increasing and increasing. For example, if this becomes 10 newtons, that becomes 10 newtons. If that becomes 20 newtons, that becomes 20 newtons. But there's a value of friction called F max, okay, which in a particular situation, it cannot increase on, and that's given by mu, which is a coefficient of friction, times the value of R. If the frictional forces reaches that value and the pulling force exceeds that value, then the frictional force will not be able to oppose that pulling force anymore, and it will start accelerating. Okay, so F max is given by mu R. So in this situation here, we're going to find the least possible value of mu. So we can see that these forces here are fixed. Okay, the force pulling up is fixed. The frictional force, the reaction force is fixed. Okay, the weight is fixed. And so the thing that we have to consider is the frictional force. Now, if we want to find the least possible value of mu, what we assume is that in this situation, F max has been achieved. So this is where F max is achieved. Okay, in that case, that will be the least possible value of mu, because if F max can be bigger than this, okay, if the F max can be bigger than the value that will be given in this situation, okay, that means mu would be larger because R is fixed and F max is equal to mu times R. If this is fixed and F max is bigger than the frictional force that's preventing this thing from falling down, then it means mu would have to be bigger. So the least possible value of mu is when, in this particular situation that we have now, it's about to slip down the plane. We've reached limiting equilibrium, that this frictional force is the maximum it can possibly be. All right, it cannot get any bigger than that. So that means, for example, if we were to reduce this force anymore, it would slide down the plane, for example, right? So it's reached its limit. It's in limiting equilibrium. So we have to assume that it's in limiting equilibrium, okay? And then that will give us a minimum value of mu in this situation. So we have to assume it's in limiting equilibrium. So now what we're going to do is we're going to draw the other forces acting, and not the other forces, we're going to resolve these forces acting on the object. So we're going to look at the forces acting up the plane and also perpendicular to the plane. Okay, so I'm going to resolve the forces. So let's look at parallel to the plane first. So what we have here, let me just draw a few lines to help us to make it clear. All right, we have this angle. Now, what is this angle? Well, this angle is always the same as the incline angle that the plane is inclined to. And the reason for that is quite simple, which I will just make sure that hopefully you understand. That just let's carry on this line here to make it clear. Basically, we have here a big triangle, which is this triangle over here, and a small triangle, which is this triangle over here. Okay, in this big triangle, you have, let's just get rid of this 30 now, just to have the proof. In the big triangle here, we have a right angle on this part here. In the small triangle, this small triangle, we have a right angle over here. So these two angles are the same in both the big and the small triangle. In the big triangle, there's an angle on this corner. In the small triangle, it's the same angle. So two of the angles are the same. It's like you have a triangle like this, okay, where this is a right angle and this is an angle. That is the same as this smaller triangle, where this is a right angle and this is the same angle as this. These two angles are the same, which means these two angles must be the same by angle-angle similarity. Okay, if these two angles are the same as each other, then the third angle must be the same in both of them. So if this is 30, therefore this is 30 as well. So that's just a little background for us to understand why the angle over here is also 30 degrees. You don't have to know that. You can just memorize it, but it's good to understand why. That's through similarity. So that angle is 30 degrees, always the angle made by the weight compared to the line of the reaction force, the normal contact force. And an inclined plane is always the same angle as the angle to which the plane is inclined. So I'm going to now resolve these forces parallel and perpendicular to the plane. So if we take, for example, the weight, if we resolve this, let me do it in a different color. If we resolve this perpendicular to the plane, you're going to have this 20 G newtons going through the angle that we're given, going into the angle we're given. It's like we're finding the adjacent side. So this is going to be 20 G cosine 30. Use cosine when you go into the angle. And if we resolve this force going down the plane, parallel to the plane, the component of the weight down the plane, that will be 20g, because we're going away from the angle given. We say 20g times sine of 30. Okay, and for the 25 newtons force, R is already perpendicular to the plane. The frictional force is already parallel to the plane. We don't have to resolve those, but the 25 newtons is going to have one component which is going parallel to the plane. Okay, and another component that's going to be going perpendicular to the plane. So parallel to the plane, we're going into the angle 20 degrees, going into the angle. So this time, this is going to be 25 times cosine of 20. Okay, depends on, this is the angle we're going into the angle given, so we use cosine, because it's like we're finding the adjacent side. And we're going away from the angle given, it's like we're finding like the opposite side, this direction. Okay, so that's going to be using sine, so we say 25 times sine 20. So if we're looking at the forces acting parallel to the plane, in fact, I'm going to do this so that I like to do it in this way, that it's pointing downwards. Why? Because it's about to slide down the plane. We're preventing it from sliding down, so I put down as positive. It doesn't really matter because it's in equilibrium, and these upward and downward forces will be equal to each other because it's in equilibrium. All right, so we have 20g times sine of 30 is equal to F max plus 25 times cosine of 20. Okay, so that's resolving the forces parallel to the plane. Now, perpendicular to the plane, we're going to have in this direction, so we have R plus 25 sine 20. Those are acting up, and acting downwards is 20g times cosine of 30. So now we know that F max is equal to mu R. Therefore, mu is equal to F max over R. Now we can see what F max is equal to from here. F max is equal to, I'm going to leave it in its exact form, and then we'll work out the answer probably later. So 20g sine 30 minus 25 cosine 20. And we can say R is equal to, from here, we got 20g cosine 30 minus 25 sine 20, and therefore we can say mu is equal to, we can divide them, we have 20g sine 30 minus 25 cosine 20 divided by 20g cosine 30 minus 25 sine 20, and that gives us our answer. So we have 20g, which is 20 times 10, 200, sine 30, minus 25 cosine 20. Make sure we haven't made a typo there. So 20g, which is again 200, cosine 30, minus 25 sine 20. Make sure we're in degree mode. We are. Equals, and we get 0.464655. 0.464655 continues on. So therefore we can say mu to 3SF, as we should round our answers, is 0.465. Okay, there's the answer. Okay, to this question. And this is this A and B here, so that's done. That's question number 4 from the specimen paper. Okay, I hope that was clear. In these type of questions, when you have inclined planes, just doing this, resolving the forces, will give you most of the mark of the question. Even if you didn't know what to do afterwards, that will give you most of the marks. But anyway, that concludes this question. Other questions from this particular paper, the specimen paper, can be found in the playlist, which will appear in this region over here at the end of the video. You can click on that link. Other questions from statics from my M1 collection from Cambridge can be found in this playlist over here. You can subscribe to my channel by clicking on this link. You can watch the video that you'll find linked at the end here to show you how to use my channel and find all my index for my different courses that I have answered questions for. Thank you for watching, and see you soon.